Good evening, Anthony. Looking forward to our discussion on Viterol, formerly known as vitamin D. And we're going on a journey into an extremely confusing topic. Not so?
Well, that's right. Now, Viterol, formerly called vitamin D, is one of the most important things to get right if you want to be healthy. And that applies to all ages. And a huge strides forward in public health can be made if we get Viterol right. But the problem is that it's a complicated business. It's a complex business. It's a confusing business for all sorts of reasons. And, one could think of 30, 40 aspects of Viterol, formerly known as vitamin D, and all of them are confusing. There isn't a single aspect of Viterol that is not confusing. And so what we should do, I think, Anthony, is not try to solve the world's problems, but to present to listeners for the first time a really clear layout of exactly where the confusion lies in all of these various facets of this wonderfully complicated and complex biochemical entity.
Great. Looking forward to it. It'll probably be many parts to get through 40 layers of confusion.
Well, not only many parts, but somewhat discombobulated to start with, because we're kind of climbing a learning curve as we go along.
Right.
And so listeners shouldn't expect us to be terribly well organized in our thinking or even terribly articulate, but we are adhering to a central theme in the system in which we present this, because we keep on coming back to the common denominator of confusion. And the idea is, to listeners, it's only when you understand exactly what the confusions are that you can then investigate and come to your own conclusions.
Right. Okay. And perhaps we should encourage listeners to comment if they have some angles for entry into the confusion. Please to leave us some links below or comments below.
Well, ideally, yes, it would be a collaboration among many interested people. So yes, please, listeners, jump in and have your say. Yeah.
Good. What confusing layer springs to mind as the one you'd like to tackle? Is it arguably the most important layer, the most confusing layer, or just the one that's the forefront of your mind right now?
Well, I think the logical place to start is with the name. And we've already mentioned a name that most listeners will never have heard of before, Viterol. And
right.
That is spelled Viterol.
Yeah.
And Viterol is a better name than vitamin D for all kinds of reasons. And it solves the initial and definitive confusion, because one of the most confusing things about the old appellation vitamin D is that nobody thinks that this is a vitamin. There is no controversy among the experts on this substance or series of substances, or it's more like a process in which one substance is translated into another. Nobody thinks it's a vitamin.
Yeah.
It was initially called a vitamin, and that's why it was given the letter D, because it came after A, B, and C. But that's like a 100-year mistake, 100-year-old mistake. And all that's happened is, in the inertia of science, that blatant misnomer has persisted.
Right.
And the trouble is that, you see, we're up against two things. Firstly, there's a kind of an inertia and a reluctance of scientists to take the responsibility of being the one who changed the name, because there's a tremendous responsibility there. And initially, the risk of mockery and ridicule and accusations of pedantry and so on. And secondly, there's no actually better category, because if it's not a vitamin, what is it? Well, some people say it's a hormone, but it isn't really a hormone, in the sense that, when the sun falls on your skin and a certain photosynthetic reaction takes place in the oil of your dermis, that is not a hormone that is being produced. You could call it a pro-hormone if you like, but it's a very complicated business in which there's a precursor and then a pro-hormone and then a second pro-hormone and then finally a hormone. But and again, this thing called vitamin D is not a single thing. It's a whole constellation of things.
Yeah.
There's a form of cholesterol, there's calciferol, there's ergosterol, there's calcifediol, and there's calcitriol, and more. And so what we're talking about is not a single thing. It's a process, more or less. And so we have to come up with a completely new term. It's not a vitamin, it's not a hormone, it's not an enzyme. What is it? Well, there is no category in biochemistry for what it is, but we can give it a new name at least. And that name is Viterol. And that name Viterol works beautifully well because it retains the familiar tag of vit, as in vitamin, which simply means referring to life. And then the erol part makes sense because this complex of entities is basically cholesterol based and oil based. So erol makes sense. So we have Viterol.
Great.
It's also shorter than vitamin D.
Yeah. So it's a complex of organic molecules, and with one right at the end of the process of transformation from the skin and finally towards an end point, which behaves very much like a hormone. What is that final molecule doing?
Well, that final molecule seems to be doing all sorts of things. It seems to regulate and modulate the immune system, sometimes boosting the immune system, sometimes depressing the immune system. It seems to affect calcium metabolism, sometimes boosting the concentration of calcium in the blood, and other times possibly reducing it. It's a regulating hormone, and moreover, that final substance, calcitriol, it communicates among cells. It's a communication messenger among cells, but it does many different things, and there's a lot of research going on all the time that adds to the pile and the list of all the different things it does. I suspect that if you dig deep into the primary literature, you'll find 20, 30 different things that calcitriol does in the body, and the list is growing all the time in proportion to people's imagination and energy in investigating it. So
it's this multi-functional biomolecule. We heard recently that veterinarians use it, inject it to boost the fecundity of sheep, for example.
Well, yes.
There would just be one of 20, 30 different functions, and that's part of the confusion.
Well, that's right. And you asked about how it relates to the category of hormones. Well, I'll give you two possible examples of where it deviates from any neat categorization as a hormone. Firstly, apparently in response to inflammation or infection and other immune crises, this hormonal substance called calcitriol is used consumptively, which is odd for a hormone, because hormones normally circulate in the body, sending messages like messengers, and nobody shoots the messenger. The molecule visits one tissue and deposits its message, and then it goes to another one. And so hormones are meant to circulate non-consumptively without being consumed along the way. But apparently, an odd thing about Viterol is that you could have a concentration in your blood of, say, 100 nanomoles per liter, but when you get an influenza bout, or if you have some strong inflammation, like because of a broken scapula, or maybe you're scared of something and you have an emotional reaction, then what happens is this hormonal substance gets depleted because it gets used up. And so if you want to maintain your immunity in the face of, say, a viral infection, a smart thing to do is to top it up immediately that very day so that you can retain your baseline level of concentration of the substance in the body. So that's a bit different from a hormone. And so the term hormone, it's a bit like a square peg in a round hole too. And I think we should just abandon the whole scheme of categorization.
Okay.
of vitamin versus hormone versus enzyme. Just get rid of the whole idea because it doesn't help in this particular thing. Let's just call it Viterol and then account for it. And the other, I just wanted to make another quick point about how it may deviate from being a hormone. If you look at ruminant animals, sheep, bosts, goats, and so on, which are very important in human economies, it seems to be a bit of a mystery how this whole Viterol thing works because they have a very rapid metabolism, growth, and reproduction, but the concentration of Viterol in their blood is the same as in slow-growing and slow-reproducing humans who have a relatively slow metabolism. And nobody seems to know exactly how that happens, and I suspect it's because the microbial system in the forestomach of ruminants produces various factors, biochemical factors, that then exercise a complex regulatory effect on Viterol, making the Viterol more efficient. So, we're really in our infancy in terms of understanding Viterol. And we'll keep learning for many years. We'll keep climbing this learning curve. But at least what we can do for listeners is spell out exactly where the different departments of confusion lie.
But I think listeners may want to understand why we don't see it as a vitamin. What's appropriate about the names vitamin A, B, and C that doesn't apply to D?
Well, a vitamin, as I understand it, was originally conceived as a food component.
Right.
It's confusing because there is an aspect of Viterol that is food-based, because you can indeed, for example, eat cod liver oil and boost your Viterol that way. But the fact that you can also photosynthesize it in your skin, in your dermis, based on an oily precursor, is completely different, definitively, from any vitamin.
Right.
And so it has a vitamin-like aspect in the sense that you can eat it and boost your status that way. But you see, even there, it's not strictly vitamin-like, because the stuff that you eat, which is calciferol, for example, if you're eating cod liver oil, then what you're actually consuming is what they call D3, which is calciferol, and that is not a vitamin because it's not biochemically active.
Yeah.
So you see, so the more you look at it, it has vitamin-like aspects, but they're not strong enough to justify shoehorning the whole bang shoot of and tutti into the category of vitamin. It just doesn't work. And in fact, I don't think any expert on Viterol today would defend it's still being called a vitamin. It's just an outdated and misleading practice that we should strenuously get rid of. It really needs a new name. Initially, it'll be awkward and embarrassing to use the new name, but somebody has to take the lead, and we don't want to find ourselves in a century's time still being hobbled by calling this thing, by a completely inept and lame name. We need to grow out of this now.
Yeah, and the term steroid also just not anywhere near suitable.
Well, it is the final hormone, the one that's produced by the kidney and is the active ingredient, as it were, in immunity and calcium metabolism and maybe 20 other functions in the body. As I understand it, it is indeed a steroid, analogous to, for example, testosterone. So there is a sterol. The word sterol, as in cholesterol, refers to an oil-like or lipid-like substance.
Yeah.
And that is a common denominator between the whole testosterone phenomenon and the Viterol phenomenon. So it is hormone-like in that sense, in that both the end hormone in Viterol and a hormone such as testosterone do appear to be steroid hormones. Of course, the biochemistry is very complicated, and you need to have special training to be clear as to what you're saying there.
Yeah.
But again, just as it's kind of shoehorning it to call it a vitamin, it's also shoehorning it to call it a hormone. And there's just no point in trying to keep shoehorning it in this way. There's no real profit intellectually or practically in keeping on doing that.
Yeah, in fact, it's difficult to journey into the confusion using the term vitamin D because it just exacerbates the confusion. So we're coining a new word to assist us in our journey.
Well, that's a very good way to put it. We have to weigh up on the left hand versus the right hand the risks and benefits of two different scenarios. On one hand, you can keep calling it a vitamin, in which case you have a certain kind of confusion that keeps hobbling you.
Yeah.
But at least you avoid the risk of confusing people with a new name. On the other hand, if you start calling it Viterol, you do confuse people because they've never heard of that and they can't understand what you're saying. But at least you avoid the confusion with vitamins, which is quite constraining. So, I think the guiding theme here is that we scientists are always trying to become clearer, more definitive, more rigorous, more precise, more articulate. That's the general theme. So even though there are risks and benefits in both keeping the old name vitamin D and adopting a new name, Viterol, I would always go for the more, shall we say, progressive, the more courageous, the more clear option. Because that's what we scientists do. We look at a confusing world and we try to clarify always. And words are very important. If you can't give something a decent, clear word, you can't think clearly about it. It's as simple as that. You need to define your terms as a matter of priority if you want to think clearly about anything in the world.
Absolutely. So now, what layer of confusion do we want to look at through this Viterol lens?
Well, one thing that springs immediately to mind, and here we don't need to make any pretense of prioritizing this for any reason, but this jumps immediately to mind, is the confusion between the kind of sunlight that it takes to photosynthesize the precursor in your human skin, which is ultraviolet B, and the kind of sunlight that it takes to photosynthesize the precursor in marine algae that are then consumed up a food chain that results in the production of cod liver oil in the cold Atlantic waters of Europe. Okay, so what's confusing about this is that it's different wavelengths. And this is seldom stated clearly. For example, with human dermal photosynthesis of the Viterol precursor, it takes a certain intensity of sunlight that you only really get under quite restricted conditions, because you have to be fairly close to the equator, and you also have to wait until the middle of the day so that you can get fairly direct sunlight that's not filtered out through the ozone layer. So, for example, here where I live in Australia, I can go out on a bright winter's day in a Mediterranean climate, and I can get quite badly burnt because we have a very sunny climate even in winter. And, we live at more or less the latitude of San Diego. And so it's blissfully sunny, but for 6 months of the year, ostensibly, I cannot make a single molecule of Viterol in my skin because the UVA that burns my skin is not the same as the UVB that triggers photosynthesis of a Viterol precursor. So the photosynthetic system in the skins of animals is pretty demanding. You don't just get sunlight; you have to get a particular intensity of sunlight that is quite difficult to get, particularly in a sun-shy society that fears skin cancer and so on. Most people don't get any really significant amount of sunlight that can make vitamin D or Viterol in the skin. It's much harder to do than most people think. And above a certain latitude on the globe, corresponding to about where the Alps are in Europe, and about where the Canadian border is in North America, above that latitude towards the pole, ostensibly, there's never a time in the year at all where you can get any significant amount of sunshine that can supply you with Viterol. And so what's confusing is that demanding standard of UV light does not apply to the food chain that produces cod liver oil, because there's a different kind of biochemical process in the sea, in
Mm.
which at far lower temperatures and in far dimmer light, the algae, the planktonic algae near the sea surface, make quite considerable amounts of the precursor. And then this basically gets into the food chain quite a lot by sort of detritus, planktonic particles falling to the seafloor and then being eaten by, for example, the cod, Gardus. And then the cod accumulates quite a lot of Viterol in its oily tissues and including in its liver. And so Europeans have very little access to the kind of UVB that gives them Viterol in the skin, but they can supplement from the sea. And that's how, European civilization has proceeded. The Europeans succeeded because of the marine source of Viterol, and despite the fact that they live in a dim climate that hardly ever gives them much Viterol through their own skins.
Yeah, fascinating, Anthony. Thanks. Is it true to say it's a photosynthesis, both in the algae and in the human skin, when it's perhaps a more passive chemical reaction? I'm thinking of irradiated milk. You can radiate milk, and there's a transformation of organic molecules in the milk that generates Viterol in the milk. That's fortified, vitamin D fortified milk, and that's a passive irradiation triggered chemical reaction. Do you think that's what's happening in our skin and in the algae, or is there are the biochemical pathways geared towards actually manufacturing it in a similar way to photosynthesis, where carbohydrates are manufactured by plants?
What a fascinating question. So what I hear is the fundamental confusion is between the word photosynthesis and irradiation. Because we when we think of harmful ultraviolet A radiation, solar radiation, we like to think of that as radiation, because the word radiation generally has a sort of tinge of danger about it. Whereas photosynthesis we think of as this clean, green, cool process in which sugar is made in plants. And so when I use the word photosynthesis with respect to Viterol, I am departing from the norm. Not many people are bold enough to use the word photosynthesis in reference to what happens in your skin on a sunny day, or what happens in the planktonic layer at the surface of the North Sea in the northern summer. The reason I use the word photosynthesis is because something chemical is happening based not only on the energy of the sun, but based on particular wavelengths, much as happens in plants. It's only certain wavelengths that plants can use to make sugar. Yeah. Now, the criticism is that when you take carbon dioxide and water, as a plant does, and you make carbohydrate and oxygen out of it, there's much more like a synthetic process going on, because you're taking simple molecules and you're making polymers. Well, glucose is not strictly a polymer, but glucose is a much more complex molecule than either carbon dioxide and water. So there is much more like synthesis going on. But there is a kind of a photosynthesis going on in your skin, in the sense that you're taking you're taking a cholesterol molecule, and then you are changing it molecularly using the energy of the sun at a particular wavelength. And in that loose sense, it's photosynthetic. And if you think about it, when you irradiate milk, you take a liter of milk, you put it in a special machine, and you irradiate it with UV. And the UV, penetrates the carton and penetrates through the milk and triggers a biochemical reaction in the milk. In a way, that's the same kind of photosynthesis, because the irradiation is by means of light. After all, ultraviolet is a form of light, as is infrared, as are X-rays. X-rays, microwaves, all these things are light in the sense that they're all electromagnetic radiation. So there's no objective difference between ultraviolet and visible light in terms of being solar radiation. They're all solar radiation.
Yeah.
And so you could argue that when you enrich dairy milk by irradiating it with certain wavelengths of ultraviolet, you are actually applying a photosynthetic system, although that may seem like a bit of a stretch. So that's another plane of confusion there.
Yeah, yeah. Then what really puzzles me is how the Europeans in Central Europe, away from the coast, managed to have sufficient Viterol in their system to get on with their enterprises. Do you think there's been a trade in cod liver oil for time immemorial in Europe to prevent extreme Viterol deficiency across inland Europe?
Well, let's come back to our common theme of pinpointing exactly what the confusion is. So this is the confusion. We know that in Europe, where the Industrial Revolution started, there were two potentially main sources of this vital biochemical substance that we call Viterol. One was cod liver oil, and in general, the oils of various fatty fishes. And the other was sunshine. And nobody has ever thought that in Europe, shall we say, north of the Alps, the sunshine was adequate except in the summer. So we're talking about summer sunshine, places like Germany, Britain, Scandinavia, and we're talking about oily fish, as epitomized by this relatively refined product called cod liver oil. So what's confusing about this is that neither of those two things are particularly rich in Viterol. In other words, if we go by the current recommendations that no matter where you live in the world, you have to have sun above 45 degrees above the horizontal in order to have any real chance of photosynthesizing in your skin. And you also consider that most of Europe is north of 45 degrees latitude. Using those recommendations, there should be no photosynthesis going on in a place like England at any time of the year. Even in northern France and in Germany, using those criteria which are given to us in the literature, we should not expect European people to have produced any Viterol in their skin at all. So something doesn't add up there. And on the other hand, also, when you actually look at the quantities of Viterol in cod liver oil, they're not that great. I mean, in order to meet your average daily requirements, if you're working, say, in a factory in the Industrial Revolution in London at the turn of the 19th century, you would have to eat about 6 tablespoons of this ghastly tasting substance, cod liver oil, every day. And poor people probably did not have access to that. And many of them would not have had the stomach for it. And so nothing seems to add up. It's confusing because clearly people were sufficient enough to have the energy and drive to civilize the world, in a magnificent new technical way. But we don't really understand where they got their Viterol from, because England seems much too dim for photosynthesis in the human skin. And even this wonderful boon, this serendipitous boon of having a sea around Britain that contains these wonderfully oily fishes that do accumulate Viterol in their food chain, even those are not that super duper that we really understand the whole economy of where Europe got its Viterol.
And is there any evidence that we know of that points to the rulers or the aristocrats knowing for thousands of years that this Viterol is needed for their empires to grow? Perhaps we need to do some reading on the Roman Empire, but I'm anticipating the Romans expanding into Central Europe, and one would think that a Viterol deficiency would cause them to their strength to deplete as they venture inland, unless they're finding a way to supplement. So it's a bit like the scurvy issue until an understanding of vitamin C arose. It was very difficult building your empire because scurvy just afflicted your explorers and your troops. It's strange to me that we don't have an equivalent story around rickets and empire building.
Well, that's right, and we could approach this historical puzzle from all sorts of different points of view. And of course, it would be a good idea for historians to have this search image in mind when they review the history of civilization in Europe. But let me use that as a kind of a jumping off point to mention another aspect of confusion, more or less at random, that kind of feeds into that, and that is this whole question of how much Viterol is there in dairy milk. This is very confusing. It's very confusing for the following reason. Okay, the infant bovine, a calf, depends entirely on its mother to get Viterol. There's no other source, and it grows fabulously fast. I mean, a bovine animal grows at least tenfold faster than a human infant, and it also has a much more rapid metabolism. And so we should expect the demands on Viterol to be great in the first months of life in a bovine animal. And yet we're told that the amounts of Viterol in dairy milk are so tiny that they're essentially negligible, unless you put the milk through a special radiative process, which then sort of fortifies it with Viterol. But you see, this doesn't make sense, because how can it possibly be that milk, which is the only source of Viterol for a demanding bovine infant, is so poor in Viterol? It could well be that a wild bost, a wild bovine, has a certain concentration of Viterol in its milk, which it produces in modest quantities as needed by the infant. But then when you selectively breed bosts and you pump them full of nutrients and often pharmaceutical products to kind of inflate the food supply on an industrial scale to produce a dairy industry, it could be that there's some kind of switch mechanism biochemically in the animal's metabolism where it simply doesn't need that milk to have the usual concentration of Viterol. But nobody seems to have investigated this, and that discordance, as it were, that anomaly between what must be happening in the wild and among the ancestors of bovines and what's happening in the dairy industry. Nobody seems to have noticed that there's something doesn't add up there. And I just wonder, for example, if you go to the Maasai in East Africa, who have far less extremely bred bosts, they have something closer to a wild type animal that produces quite modest quantities of milk in a much more natural free range situation, a much smaller type of cow. I wonder whether the milk that they drink, which is closer to natural, might actually be quite a good source of naturally produced Viterol. Nobody seems to have thought to research that.
Linking back to the Romans, it's possible that they were drinking milk from more natural livestock and with a greater Viterol concentration than today's milk.
Yes, you see, it raises that possibility. It raises the possibility that the penetration of Caucasian people into Europe and their burgeoning civilization, their economic strength, might have been based not only on a combination of sunshine on the skin and cod liver oil or similar products from the sea, but also a third source, which is Europeans might have invaded Europe hand in hand with livestock husbandry.
Yeah.
And if those species of livestock, not only bosts but also sheep have been used to produce milk, and so have goats. So between sheep, goats, and bosts, and in some parts of Central Asia, horses, the domestic horse was used for milk as well. The Mongol culture used, they not only used the horse to produce milk, but they actually produced alcoholic beverages from that milk.
Right.
But you see, it could well be that the dairy, the sort of primitive dairy food source, was quite important for Viterol in the original European cultures. I just don't know. I'm not saying that it was or it wasn't. I'm just saying that one of the casualties of this confusopoly is that questions like that haven't even been thought up. There's been no search image even to think of those things.
Yeah, and it's interesting in this context to contemplate that the livestock industry routinely injects Viterol into sheep and probably other livestock, enormous amounts relative to the supplementation that humans routinely undertake. That's right, isn't it?
Well, that is right. Of course, to be sure of that, one would have to take a deeper dive into the veterinary and agronomic literature. But it does seem that livestock husbanders are prepared to give parenteral doses, that's injected doses of Viterol in livestock that no GP in the human sphere would dare to do. Yeah. And so that raises the other question. Well, if that's true for the bovine animal, then how come that Viterol is not coming out in milk? We're used to being told that egg yolks have got quite a lot of Viterol, formerly known as vitamin D. But then it's explained by the fact that the fowl are fed relatively rich sources, and so it accumulates in the egg yolk. Yeah. But if livestock are supplemented as intensely as we've read that they are, particularly with calcifediol, which is the form of the pro-hormone synthesized in the liver, but can be artificially supplemented. If that's true, in order to boost livestock health, production, productivity, metabolism, and so on, why is it that in the dairy industry, the Viterol is not coming out in the milk? I just don't understand why milk is so poor in Viterol. It makes no sense to me.
It's possibly that the vets are only injecting when the animals are being used to breed, as opposed to just generate milk for humans.
Yes, it is possible. It is possible. Yeah. But it's still puzzling because, for a dairy cows produce prodigious quantities of milk. It's perfectly astonishing what selective breeding and artful nutrition have done. They've boosted by an order of magnitude the capacity of an animal to generate milk. And that involves very rapid metabolism. It's a terribly demanding thing, So you'd think that if you're keeping your dairy animal at the level of metabolic activity that can sustain a dairy industry, partly by means of making sure that it's absolutely sufficient in Viterol, you'd think that Viterol would come out in the milk.
Yeah. No, I agree. I'm looking forward to a deep dive into that literature to try and figure this out. We've been going 38 minutes, Anthony, and I think if we could draw our part 1 to a close, and looking forward to part 2, because we've only looked at a couple of layers, and as you said, they're probably 30, 40 plus. So thanks very much, and look forward to part 2 soon.
Yes, thanks. And to listeners, please like, subscribe, and share. And please be patient with us, indulgent with us, because we're rambling all over the place quite deliberately because, after all, we are trying to clarify confusion. And by definition, the confusion is confusing. So bear with us and enjoy the ride as we slowly explore all these different aspects.
Excellent. Chat soon.
Chat soon. See you later. Bye.